Hi everyone, welcome back to the Tensorflow tutorial series. This time we'll finally go to the RNN recurrent neural network. And before the example, I highly recommend you to go through the tutorials that's created by Google, and I will show the links in my description about this tutorial. And this tutorial is introduced what is RNN and compares the CNN and RNN and what is the difference between CNN and RNN. Basically, the RNN is to learn the sequence of data that's based on sequential order of the data. So you will go through that tutorial and then come back to my tutorial, because I will talk about the terminology from that tutorial, and I will use the LSTM, which is the long short-term memory. If you don't know the LSTM, then you will look at the tutorials over there. This one is to introduce the basic RNN, and this one is to introduce what is LSTM, long short-term memory. Basically, long short-term memory is to fix the RNN's problem. Yeah, I already assume you have gone through the Google's tutorial, and now let's start. So this tutorial is based on the MNIST dataset, which is the digit from 0 to 9 pixel of digits. You'll find the original codes in this link. I also include this coding in my description, so you can just find in my description about this code and download it and practice by yourself. So this one is based on the example in this link, and I have modified some of the parts, and I will show the other one's part in my coding. So basically, we're going to create load the MNIST data and set the hyperparameters, and creates two placeholders for x and y. And here is, I will create, for this tutorial, I will create 3 layers to show you this picture. So if you have to look at the RNN, it's just a sequence of neural network. So this is a simplified version, and I will use 2 layer plus 1 cell, this structure. The 1 layer is the input hidden layer for manipulate the input, and another layer is the output layer for calculate the output from the cell. We call this RNN as a cell. So from the cell, go to the output hidden layer, then output the final answer. So 2 layer, 1 cell. This is my structure in this tutorial. So for input layer, we use the weights we have defined in here. The weights for input layer is the weights over here, has the shape of an input and n hidden units. The hidden units is the unit for the cell. So let's look at here first. So firstly, for the RNN, we're going to create 1 hidden layer for input layer, and in the middle we create the cell. And in today's tutorial, we are going to use the LSTM cell, that is the long short-term memory cell. And here, this one is the output layer. So for input layer and output layer, we define the weights and bias in here. And then we're going to calculate the function return. The return of this function is the prediction of the answer. So for the MNIST data, so for example, please look at here. The MNIST data is image, alright? It's 28 width times 28 height image, and the channel is 1. So for RNN, how to describe the image, we can think about this. So for the image, we have 28 row and 28 column, right? So for each time, the RNN is looking at the time point. So for each time, we have to read through this row, entire row. for the time point A, and for the second time point, we read through the second row. So for the 28 times, we read through all the rows in this picture from the top to the end. This is the how the RNN can read the picture in this tutorial. Let's back to this tutorial. The prediction over here, the prediction is once after we read through all the rows in this picture and we conclude what is in this picture and what is the class in this picture from digital 0 to 9. So this is the prediction, and we finally use the softmax to calculate the cost or the cross entropy of the predicted results to the real result, and use add-on optimizer with learning rates something and minimize the cost. And finally, we can calculate the accuracy, and for some of the step we can print out. For every 20 steps we print out the accuracy of our result. So let's start to define. Okay, for the hidden, let's talk about the placeholder first. The placeholder normally the none is the batch size of your input, and n step in here is how many time step we're going to look at one picture. So in this picture, in MNIST dataset, we have 28 rows or 28 column or 28 column, 28 rows. We're gonna read through the 28 rows, which is the 28 time steps. So this n step is 28, and the n input is how many column, how many pixels in one row of this image. So in one row of this image, we have 28 pixels in this one row. So the n step is 28, the n input is 28 as well, and the n class is how many class we have, because the MNIST dataset has 0 to 9, 10 classes. So that is all. And the hidden unit is the hidden units inside of this cell, LSTM cell. So that is the basic. And learning rates like this, and training iteration like this, batch size 128. Display step, just ignore that at the moment. So let's start to define the hidden layer for input cell. Let me just copy and paste. You like that, I like that as well. So step by step, as the first step, we have to reshape, because as you know, the x inside x, the x is here. The x, we're going to input the x and weights and bias for the RNN. So the x, we input this lowercase of x, which is this placeholder over here. So the x is a three-dimensional batch size, n step, and input, but for the hidden layer, the weights can only multiply the wx plus b. This calculation, the w is a 2D dimension, and the x must be a 2D dimension as well. So we have to reshape the 3D dimension of x into a 2D dimension. So the x in here is batch size, n step, n input. We reshape the 3D dimension into 128 batch times 28 step. This is the first dimension, and this is the second dimension, 28 inputs. So after that, we now can multiply by the weight matrix, because this is 2D and this is 2D, then we can multiply them. And then we calculate the x in, that is the result in the hidden layer, input hidden layer here or here. So once we done that, we then going to reshape it back to 3D. This is X reshape back to 3D. 128 steps, 128 hidden layer. Hidden. This one is the hidden units in the cell. So 128 is the hidden unit in the cell. Now we're going to input this result into the cell. This is 3D, and the cell can accept 3D as well. So this two-step is to define the cell. We're going to use the tf.nn.rnn cell, that basic LSTM cell, and this n hidden units is the cell size. So I have 128 hidden units in this cell. And if you have looked at the tutorials in Google's website, you will find out for LSTM they will have forget gate, read gate, and write gate, right? This is the initial, the forget gate bias. So that is to say, first the few of steps, we want to open our forget gate, which means that we don't want to forget anything at the beginning, because the beginning is the very important parts as the learning procedure. So we open the gates and let us not forget anything, and later on we can just figure out how many we want to forget or how many we don't want to forget. Then this one will change in the future, but in the beginning we want it not forget anything. And this state is tuple. If you look at the tutorial in Google, and you will find out what is the state. The states for LSTM is actually two kind of states. One is C state, one is H state. C state is the, if you can imagine you watch the TV series, the C state is the main storyline. So to tell you what is happening in the whole section of the data sequence. And the H state is the sub-storyline. So this is the someone just entering my story. This is the moment. You can think about this is the one moment or the latest state. So that is the state for LSTM. So the state is tuple, means that we just pass a tuple of states, two states for LSTM. The basic RNN cell don't have the C state, they only have a H state. So this is different between the basic RNN cell and the LSTM cell. And in the newer version of TensorFlow, they recommend you use the stated tuple as true. They want you to use the state is tuple. The calculation in state is tuple is faster than the state is not tuple. So we just keep the state is tuple. And the LSTM cell, 0 state, that means we define the initial state as all 0. So the state takes one input as the batch size. So we just pass the batch size inside. Once we have defined the initial state, we now can use this one. So for this is the main structure in main loop in the RNN. We can use the original one is called tf.nn just RNN over here. The advanced one is tf.nn dynamic RNN. This one is better than the original one, and lots of people recommend to use the dynamic RNN. And let's talk about the this one is the LSTM cell, which is the cell in here, and this one is xin, that is the input from our last layer. And this is initial state. We just copy this initial state in here. And time is measure means that for for the inputs over here, let's look at the shape. 128 batch, 128 steps, and 128 hidden. And for this shape or this dimension, the time dimension is actually this one, because this is 28 time steps. So we have a time step in our second dimension that is not the major dimension, so we pass the false in here. If you have the time dimension in here, which means the 28 time step in here, then you will have the time major is 2. And that is that. And from this loop, we will output the all outputs in every steps. That is here. So this is, you can just imagine, this is the output from the step 0. This is the output from step 1, step 2 output. So this output is collection of all outputs for every steps, and the final state over here is just one final state in the last time step. So that is the output for the return for this function. You can look at the scripts in my GitHub, and I have a full description in these several steps. So what if you want to use the normal? What if you want to use the tf.nn.rnn? What's the difference between the dynamic RNN and the normal RNN? I will tell the difference in my script in the GitHub. Lastly, we're going to calculate the output from the cell, right? The output layer is calculate the output from the cell. So we have basically two options for you. One is this is the first option, because we only care about the last output in the last step, because the rest of them are just nothing. We only care about once you have read through all rows in this picture, what is your conclusion in the last time step. So we only care about the outputs in the last time step, and the outputs of the last time step is also the state, right? So we can use this final state, and the final state, the one, it means the age of the final state, right? Age state as the final state, and use the age state times the weight and times the plus the BIOS is the result, final result, right? And the second method use the output itself. Use the output, and we use the last output as the result once we read through all the rows. So for each of the rows, we have one output. The collection of outputs is stored in this one. So we wanna unpack and transpose the output in order to get out the last output from this output. So the last output is output indexed by -1. This is the last output. So these two steps is the same as these steps at this step. But in other examples, these two steps may not be equivalent to each other, because this is the special case. So in this example, we can use either this step or these two steps. So in here, we just use this one for testing. So that is the RNN. And now we can run our model. To test. For each 20 steps, we're gonna output the accuracy. So accuracy 18%, 65%, 72%. This is increasing the percentage of accuracy, so the model is learning something. So let me use the second method. We just remember the first output accuracy is 18 plus 75, and I already set the random seed as 1, so the randomness of all initialization should be same. So if this step is fully equivalent to this 2 steps, the first output should as the same as 0.1875, right? So I just run this again. Yeah, 1875 is exactly the same as that. So this is to tell that these 2 options are the same, right? Okay, let's stop over here. So this is the tutorial for today. If you like it, please share the tutorial, and please subscribe and watch more about TensorFlow and more about machine learning in my channel. Thank you. And next time we'll talk about how the RNN can be used in the regression problem. Thank you. Bye.